Welcome. This is Coach Dorf. We're in section 5.1/5.2, and we're looking at this homework example where we're given an expression that's a limit of a sum of some function, and we're supposed to express that as a definite integral. So the first thing I would do in this problem is to recall what is the definition of a definite integral. So we're told that an integral from a to b of f of x dx is defined as the limit as n goes to infinity of the sum I equals 1 to n of f of x of I delta x, where delta x is b minus a over n and x of I equals a plus I delta x. All right. So it's good to make sure we understand this definition here. Delta x, where's the b and the a coming from? Those are the numbers on the integral sign. And in the last one, the x sub I here, we have a sub I, x sub I equals a plus I delta x. That delta x is what we have from above. Some of you will recognize, because the fact that I is going from 1 to n in the summation, my x sub I here are like the right endpoints of the intervals in the Riemann sums. Anyway, so this is the definition here. So we're going to use this as comparison. Notice that my limit here matches the form of a limit here. And that's going to be the basis of trying to figure out then what does the definite integral look like, where the definite integral is this part here. And so in essence, what we need to do is, we're given the fact that I have the limit as n goes to infinity of the sum I equals 1 to n, 2 over n times parentheses 5 plus 2I over n to the 10th. This is what we're given, and what we need to do is we need to find a, b, and f of x. And as soon as we have those things, then we can plug them into the definite integral that we have in the blue box here, and we're able to write our integral. We'd be done. Okay, so I'm going to look at the comparison of these things here. And let me use some colors again here. All right, we noticed that I've got this 2 over n. In comparing the two circled parts, that's going to have to be equated with the delta x. All right, and remember the delta x is b minus a over n. How come I know that those relate? First, the green box with the limit and the summation sign, that comes at the beginning, right after the summation sign, while in the second red circled formula, it comes at the end. It really doesn't matter because they're multiplied together, so I can have it first or at the end. But what's important is that I have the letter n in the denominator of this first green box here, and I have in the formula for delta x, I have an n in the bottom there. That gives me a clue that those two are connected. So from that, we get that 2 over n is going to equal delta x, which is b minus a over n. Again, the key there is that I have an n here and I have an n here. And what does that tell me then? Well, that tells me that b minus a has to equal 2. That doesn't tell me what b is, it doesn't tell me what a is. But as soon as I can figure out one of those, then I'll know what the other one is. What do I also know? Well, also have that 5 plus 2I over n to the 10th has to equal f of x sub I. How do I get that? Well, I look back here at my original problem. I have 5 plus 2I over n to the 10th. And that's going to have to equal f of x, because that's the only thing that's left after the summation sign. So those have to equal each other. And then I'm going to use the fact that x sub I, let me rewrite that one, x sub I is a plus I times delta x. So I'm going to put that in here. So this is f of a plus I delta x. Again, that comes from here. All right, and I already know what delta x is, right? Delta x is 2 over n, so I'm going to put 2 over n here. All right, so what does this suggest to me? I'm going to look at, let's use some blue here, I guess. I'm going to look at this formula and this formula here. What do I see with those parts there? Well, I've got this I times 2 over n and this 2I over n. That's really a good sign. And then I also have this 5 here and this a, right? That's going to suggest that a equal 5. Okay, then give me that of 5 plus 2I over n, where I'm just taking this formula here and plugging in that. A is 5, and I'm getting that, right? And that's going to equal 5 plus 2I over n to the 10th. And you may say, where does this last part come from? Which I will really use another color here. Let's go back to green here. Where does this come from? That comes from the fact that we had that right there, right? Two parts were equal. All right, so what does this tell me here? Now I've got f of this parentheses equals this parentheses to the 10th power. So that's like saying f of some big parentheses is going to equal parentheses to the 10th, because whatever's inside here matches what's inside here, just like we have it up above here. It's inside equals what's inside there. And that suggests to me that f of x is going to be x to the 10th. Whatever I take, whatever x is, then I put it to the 10th power and it works. All right, so what does that give me? So we get then that b minus a is 2, but we figured out that a was 5. So that tells me that b is 7 equals 5. And we had from up here f of x is 10. Those are the three things we need in order to write our integral. So that gives me integral from 5 to 7 of x to the 10th dx. That's my final answer. All right. Now, let's suppose I change this problem a little bit. Now, let me rewrite this a little bit clearer here. That's the integral from 5. Okay. Let's change this just a little bit to the following problem. Remember, the one we had before was I had the limit of the summation of 2 over n of 5, in parentheses, 5 plus 2I over n, everything to the 10th power. Let's change this now to the limit as n goes to infinity of the summation I equals 1 to n of 2 over n, 5 plus parentheses 2I over n to the 10th. Okay, put a little square bracket there. Notice how this is different than the original one. The original one, we had the 10 exponent outside of the parentheses. So the 5 was inside. And in this one, we just have the 2I over n to the 10th power with the 5 outside of that. All right, so suppose we have that now. What happens? Well, again, look at the definition. You have the integral from a to b of f of x dx equals the limit as n goes to infinity of the sum I equals 1 to n f of x of I delta x. And again, that's delta x is equal to b minus a over n, and x of I equals a plus I delta x. All right, so just like before, we're going to get that 2 over n is going to equal delta x, because we have this and this, and those are going to equal each other. And again, I see that because I know delta x is equal to b minus a over n, and the first red circled one I have 2 over n. The fact that both of those have n in the bottom is really helpful here. Right, and so like before, I have b minus a equals 2. Okay, and also, like before, right, a function 5 plus 2I over n to the 10th is going to equal f of x of I, which would be f of a plus 2I over n. Could a equals 5 this time? Because before it did. How about this time? Well, if it did, then we would have f of 5 plus 2I over n would equal 5 plus 2I over n, the last part to the 10th power, right? Because, again, if we're going to say a is 5, we put 5 in there, and then that would mean that this part would be that, and that has to equal this part here. So that's where those come from. All right. If I did that, then what is f of x in that case? Well, then I would have f of parentheses equals what? Could we have f of x equal x to the 10th in this case? Well, no, we couldn't, because if we did, we'd have f of 5 plus 2I over n. If it was x to the 10th, then that would be 5 plus 2I over n, everything to the 10th. But that's not what we have, right? That doesn't equal this part here, doesn't equal this part, because that's supposed to be 5 plus 2I over n to the 10th. All right, so what I have here in green doesn't equal that. Those aren't equal to each other. So I can have f of x to the 10th. Could we have f of x equal 5 plus x to the 10th? Well, again, no, because if I did that, then I would have f of 5 plus 2I over n. Plugging that into the formula for f of x that I have right up here, I would have 5 plus parentheses 5 plus 2I over n to the 10th. And that doesn't equal 5 plus 2I over n to the 10th, right? Which we have from here. Those aren't equal to each other. So we can't have a equal 5 in this case. So what would a be? Well, we could have a equals 0, in which case then we would have, remember, fa plus 2I over n. If a is 0, plug that in here, we're going to get f of 2I over n, and that's supposed to equal 5 plus 2I over n to the 10th. And what would that give me to be f of x? Well, f of x would then be 5 plus x to the 10th, because the 5 is still there, and this is what changes. So equals 0 works, and that would, since the difference between, since b, a, or, let me write that, since b minus a equals 2, that would give me, we'd have b equal 2, and so we have three things we need. Remember, we need a, we need b, and we need f of x. And so from that, then we can get the integral a to b of f of x dx is going to equal the integral from 0 to 2 of 5 plus x to the 10th dx. And that would be my answer there in this case. So see how the first problem was different than the second one here. Hopefully that helps.